Now, Boolean values in programming are needed when you want an expression to result in either true or false, right? So Boolean will either be true or it will be false, which means that whenever we evaluate an expression, there is one of two answers, either true or false. For example, if I write print 10 is greater than 9, and if we also say print 10 is equal to 9, and then we also have print 10 is less than 9. You notice the result comes as true, false, and false, which means that 10 is definitely greater than 9. It is not equal to 9, and also it is not less than 9. Let us do a simple if statement. So I will say that A is equal to 200 and B is equal to 33. And we say that if B is greater than A, then we want a result which says that B is greater. Else, we will say that A is greater, like this. So when you run it, you get that B is greater. If this was 333, then the result would have been, I'm sorry, if I run this, it says A is greater, but if I make it 333, then the result comes as A is greater. All right, let's see what else I can show you. So you can also use the bool function, which is BOOL. For example, if you say print bool and then you say hello, the result comes as true. Now, obviously, it is going to come as a true because it is simply evaluating a value. For example, even if you had said print bool 15, then also the result would come as true only. So most of the results that come when you evaluate a value comes as true. Right now, you might not see the value in doing it, but there are cases where this might help you. For example, even if you're writing a function and you say return true and you say print my function, the result comes as a true. Like I said earlier, don't bother with this right now. When we do more lectures, then this concept will become clearer. I do want to give you one more example right now. If I define my function and let's say we are returning true, and imagine we had an if statement here. So I say that if my function print yes, else I want to print no. Now the result will come as yes here, right? Okay. Now that we've done this, let's also look at operators. So obviously there are different types of operators available. So we have arithmetic, we have assignment, then we have comparison, logical, identity, membership, and then finally bitwise, which is for binary numbers. So your basic arithmetic operators are addition, subtraction, multiplication, division. Then you have a modulus, which is a percentage. Exponentiation is two asterisks, and a floor division is two slashes. You also have various assignment operators. Some of these might seem a little complicated right now, but that's the reason I've given you the explanation. For example, if you look at any one, let's say the second one, you would see that x is equal to x plus 3 can also be written as x plus equal to 3. Why do we do it? There's no reason for it. It is just a programming convention, and programmers would typically write x plus equal to 3 rather than writing x is equal to x plus 3. And similarly, there are a lot of other examples given, like this is an exponentiation, which is x double asterisk number 3. We can also write as x double asterisk equal to 3. Then we have comparison operators. Very simple. Equality is always a double equal to. Remember, a single equal to will always be an assignment. So if you want to check if x is equal to y, then you have to use two equal to signs. Not equal to is an exclamation mark and an equal to. Greater than, less than, greater than or equal to, less than or equal to is the same as we use in Excel as well. Of course, you have an and or operator, just like you have in other programming languages. We do have other types of operators. We have identity, membership, and bitwise, but these are not really important for us. Identity is something I already showed you, which was that is and is not. Membership is very similar. It is in and not in. And bitwise is used for binary numbers. So this would not really be something that you need to bother yourself with. Excellent. In the next lecture, we will look at lists, tuples, and sets and dictionaries. So it's going to be a long lecture, but we will cover a lot of important topics on Python.